Hey, hello everyone, welcome back to my YouTube channel. And I also welcome back to our Kubernetes project series. And this is the third project of our Kubernetes series. And if you are new to our this series, I recommend you to go back and watch our previous two videos so that guys can get a overview of what problem we are trying to solve in this today's video. So so this is the third project of our Kubernetes series. Let me show what we are deploying today first. So this is the application that this is just simple a React application, rating application where users can rate a customer's store. So let me first log in into this and show you. So this is just simple, and this application has multiple users like a normal user, store owner, and admin. So this is the normal user, and this is the interface for him. So he can just simply rate the stores here. He can see multiple stores. He can just simply rate these stores, or he can just search any specific store he want to, or else he can filter out the stores based on ratings like this. Sort by name, rating, and all. He can view his profile. He can update his name, email. If you want his update, he can password also. All these things. And now let me show you the other user interface. So this is the admin dashboard, and admin dashboard can view how many users we have in our application, total stores, and how much rating has been happened. All the users in our data like name and email with their label, and can also view the store. And you can also add the new store here, and can also my user management add any users name, email address. He can add you. Similarly, he can also view his profile page. This is the and we have another user. So this is another user. This is the owner dashboard. So you can see the owner dashboard. He can view his store all details, how many total reviews have happened, how many five-star rating trend, who all has rated him, review all customers like this. You can also view his dashboard here. So this is what we are deploying today. And yes, guys, if you guys are new to my channel, please make sure to like and subscribe to my channel because it really motivates me to make more such content. And do follow me. And yeah, without getting late, let's get started. So this is the third project of our series, and in this video, we are trying to look into the drawbacks that we faced in our previous videos. Like we have today that is stateful sets. What is this stateful set? But before that, you should know what is this stateless versus stateful applications, and then we will look into the stateful sets. Why we need to use this stateful set over the deployments, all these things I will explain this. And then next we have this headless service, and then next storage classes which will help us to dynamically provision our volume. Then next we have EBS volumes which will help us to store the volume data of our containers externally independent to our cluster. And then next we have Ingress which will help us to route the traffic. And this is the architecture of what today we are deploying. I'll explaining you this architecture once I'll explain this all theoretical concepts. And if you want the code, you can find that in this our repository that we are maintaining for this series. You can find all source code for that in this KTS folder, and documentation what is all those concepts that I've explained here. And if you want the source code of this application, you can go to for this URL. You can find the all source code for that application here. Okay, now first let's understand what is this difference between stateless and stateful application. So let's understand this. So this is just a simple pod, and you are trying to log in into one of the application. Let's say you are the user and you're trying to log in into this application. And once you log in into this application, and in this application you will be marked as authentication as true. This is the state of your now, and now you are marked as true. And next time whenever you try to again come to this same instance, same application, this application has your state and saying that you are authenticated, means you already logged in into this instance, and there will be no authentication performing for you next time. Now what happens is, if you have multiple such instances and there is a load balancer placed here, if there is a load balancer placed here, what happens is you will hit the load balancer, and this load balancer will route the traffic to any one of the instance, and you don't know to which instance the traffic has been routed. The firstly you have first the router traffic has been routed to this instance, and here the user has been marked as authenticated true. And next time whenever the user's traffic has been routed to this instance, here it is there, the user's data is not present and he is not been authenticated, so there is a problem. So what we do is here we keep our state to our database. So we don't keep our state to instance, but rather we keep our state to our database. So this is our database. And now this data instance will communicate with this database and will take the state of that application, and this will work fine. So the state is present in our database. So that is why we call this database as stateful application, and the instance, which is the front end or back end, we call them as stateless application. So this is the reason. And now you may be thinking, what's the problem in this? This is what we used in our previous video also. So we have the multiple instances of our backend and front end, and we have a single a pod instance where the user was communicating. The problem comes in when you have multiple such instances of backend. If you have multiple instances of such backend, your instance will again route the traffic to any one of the pod. And if the state is maintained in only one of the pod, then again the problem is same. That is, your state is not been maintained here. So this is the problem that stateful set solves. What happens is, let me explain it more elaborately for you. So in our previous video, we used the deployment. So this is the deployment that we used in our previous Mongo deployment in project 2, and replica we had given as replica is 1. So what was happening is, so this YAML file was spinning up a single pod, and this pod also had a volume. So this is the volume that PVC, persistent volume claim name as Mongo PVC. So this was referring to one of the PVC, and this PVC internally was referring to one of the PV. So everything was working fine. Now assume we changed the replicas as 3. So this YAML file will spin up the 3 pods, pod 1, pod 2, and pod 3. So 3 pods are spinned up. And now these 3 pods are referring to single PVC. That is this PVC. Again, these are referring to single PVC. And this PV pod will not be able to connect to this PVC. Why? Because this PVC is already bound with this PV, and single PVC will only be connect to one PV, one pod. And then if this pod won't get this PVC, they will not run. They will always stay in pending state. So this problem is solved by stateful set. What stateful set does is, every pod will get its separate PV and PVC. So let me explain it over here. So this is the stateful set. See a kind of stateful set. And here we are given the replica set as 3. Let's assume this is 3. So this 3, what happens is, in this stateful YAML file, we have a something called volume claim template. Volume claim template, what will do is, it will spin up a separate PV and PVC for separate PV. Sorry, separate pod. What do I mean by that is, so this YAML file simply will spin up the 3 pods. That is this one, and this one. And each pod will get separate PVC and separate PV also. And now the problem is solved. Problem 1 is solved. That is, separate PV will be, each pod will get separate PV and each pod will run. And the next problem is, what this stateful set solves is, stateful sets typically follows the master slave architecture. Means these 3 pods will not just spin up these 3 pods will not immediately spin up all together once. Like in deployments case, I don't know you have observed it or not, but when you use this deployment, all 3 pods will spin up immediately, and all 3 pods will be having some random name with it. But in a stateful set, what happens is, it follows the master slave architecture. What happens is, first the master pod will spin up. So first the replica set is given as 3. So first this master node will pod will start, and then after this slave will start, and then after the slave 2 will start. Same the data flow also goes. Whenever the data is written to one of the pod, first the data is written to this master pod, and then data is replicated into the master slave 1 and slave 2. So by this, data is with all three pods, and data is been persisted also. So this is what I mean by ordered pod. So this problem 2 is also stalled. And the next is sticky identity. All pods will get a sticky identity. Means we want internal communication between these two pods so that communication can happen and data can be persisted. And I also told that pods are ephemeral in nature, and if the pod is crashed or deleted, the replica set will spin up a new pod. But in the case of stateful set, what happens is a new pod is spinned up, but the name remains same what it has previously. That is Mongo stateful set 0. If this pod is deleted, the pod will start again with the same name. That is Mongo stateful set 1. And same for this also. This what happens. And now this is not enough, but there is also called as a headless service. And this headless service will come into picture only when we are using this stateful set. Why? How a headless service will be used is, so this is our headless service. In this headless service, we will be explicitly mentioning as cluster IP as none. Means each pod will be getting a specific name. And how this service, what will be the name for that service is, this is the pod name, service name that is Mongo, which namespace project to svc.cluster.local. So this is the DNS for each pod you will be getting. So this pod's DNS will be Mongo hyphen stateful set hyphen 0 dot service name is Mongo dot in which namespace project 3 dot svc dot cluster dot local. So this will the DNS for this pod, same for this and this. So there will be communication between each one of the pod. So now let's understand what is storage classes. Storage class simply is means it will help us to dynamically provision the persistent volume. So what was happening in our previous video is we were manually going and creating the persistent volume and then persistent volume claim. And then that persistent volume claim was inbound with that persistent volume. But in this storage class, what happens is we will not go manually and create the persistent volume. What this storage class will do is it will dynamically create the persistent volume for us. And then we can directly bound that persistent volume to our PVC. So what happens is, so let's look at in our this stateful set. So in this stateful set, we have a volume claim template, and in that volume claim template we have mentioned a storage class name as AWS EBS. Means this PVC is trying to create a PV from this storage class. Which storage class? AWS EBC. So this will refer to this AWS EBC, and in this AWS EBC is trying to trying to create an persistent volume from where it is trying to create provisioner as ebs.csi.aws.com from EBS. Means it is creating persistent volume from this EBS, and in this EBS is completely external, independent from our cluster. If anything happens to our cluster or node, this EBS will be completely independent. Nothing will happen to this EBS. Then we can simply take backup or scale this data or do anything with this data as we want, because this data is completely external to our cluster. So this is storage classes and EBS volumes. So now let's understand about what is Ingress. So first the question is simple. Why we need to use Ingress? When we were using Noteport, we were able to use our application simply easy. Ingress we need to use when, but in our previous video the problem was we were exposing the port, some specific port, like in our previous video we were exposing this port 30,200, and whenever the user was hitting this port, the request was being routed. So this is our front end pod, and this is the service, and this service was load balancing the traffic to one of the pod. So this is a security concern again, because we are exposing some of the ports of our node. So this is where the ingress comes in. Before Ingress, we have something different, other service called load balancer service. What that load balancer services does is that will give you some DNS. That will give you a DNS, and on that DNS you can hit the traffic, and then that was routing the traffic either to front end or back end. But the problem with that also, if you have multiple such services, so this service is for front end, this is the service for back end, and this will route the traffic to either this or this. These are the two front end pod, and this is the back end pod, and this is the user. And if we use the load balancer service, so this is now load balancer service. If you keep the load balancer service, this load balancer service will route the traffic. And if you have multiple such load balancer service, our cost will simply go high because load balancer are costly. That is where the ingress comes in. By ingress, what happens is we have just a single load balancer, and user will hit that single load balancer DNS, and then based on the request, means this is our ingress YAML. So this is our ingress YAML. So let's assume this is the host, that is myapp.local. So whenever user hits, and this myapp.local is what we say, we use the DNS, right? And we map this DNS to that load balancer. Which load balancer? That load balancer we will use here. And whenever the user will hit this host, whenever the traffic is for slash, the traffic will be routed to the front end service. So this ingress will route the traffic to front end. And whenever the traffic is for slash API, that is myapp.local.slash API, the traffic will be routed to the backend service. This is the use of the ingress. And by just one single load balancer, we are routing the traffic to the multiple such services. This is the use of ingress. And if you don't get this, wait for until we do the hands-on part. When we do our hands-on part, it will get more clearer for you. So now we will start our hands-on. So come to your AWS console, and I have already created this GitHub repository in which I have this setup.md, in which this I have explained all the steps how to set up this. Where we will, you, the only prerequisite is to you have a AWS account, and understand this, in this project we are running an EKS cluster, and EKS cluster will incur your cost. So make sure that you are aware of this, so this will incur your cost. And so in this we will firstly launch the Bastion host. Bastion host is just simply a server, and this server is not part of your cluster. Rather, through this cluster instance you will manage your cluster. And next we will install other the tools that are required for us, like AWS CLI, kubectl, ekctl, helm, and all those things. I'll explain these all step one by one. So now come to your AWS console, go to EC2, and launch a instance, a Bastion host. Give name as Bastion. Take Ubuntu. You can give any other name as you want. Take Ubuntu, and then an instance type. We will take a T2 small. Keep here. I have already this keep here, and I'll keep everything default. And setting storage configuration I will take as 25, and simply launch your instance. So now once the instance is running, just check this and connect. Take this URL and connect to that instance. So now once you are inside the instance, firstly update your instance. Next, we will install our AWS CLI. So the command for that I have already pasted here. So just copy this and paste it over here. So this will simply install AWS CLI in your instance. So once your CLI is installed, now it's time to configure your instance with your AWS account. So for that, this is the command AWS configure and give you a access key ID and secret access key ID. And I assume that you know how to create this access key ID and secret access key ID. And give region as the region you want where you want to create your resources. So for me, I am using AP South 1. Output format take as JSON. And yes, now you are connected to our AWS account. So next is to install is kubectl. So just copy this, paste it. Next is ekctl. Next is helm. So now everything is installed. So now we will start by creating our cluster. So to create a cluster, this is the command for that. And the name of our cluster that we have given is my cluster. And in which region, that is AP South 1 version, and without node group. Means we are not creating any node for our cluster. We are only creating the master node. So for that, just take this command and paste it over here. And make sure that to create this cluster, it will take minimally 15 to 25 minutes. So make sure you have the patience to for that. So it will take nearly 15 to 25 minutes to so see our cluster is now up and running, and our just the master node cluster is up and running. We have not set up the nodes till now. So to set up that, but before that we will set up associate IAM OIDC provider before that. So for that just copy this. So what is this IAM OIDC provider? I've already given the documentation brief information about that. So we use this IAM OIDC provider when we want to connect our Kubernetes resources with our AWS resources. Like in this definition I have given, a secured way to let your Kubernetes pods access AWS resources without needing long-term credentials. Like in our case, we have our Kubernetes pods, and that pods need the connection to our physical EBS storage. So for that reason, we need this IAM OIDC provider. So now let's install this. So take this command, paste that, and hit enter. See this given as a in a region and in for which cluster we are adding this OIDC provider. That our cluster name is IAM cluster. And next we will add the node groups to our cluster. So the node groups we are adding, the type of that node will be T2 medium. Two nodes we are adding, and make sure you have this key pair EC2 key pair. You give any key pair that you have in your AWS account. So just take this command, paste it, and hit enter. And again this will take again some time, like 10 to 15 minutes to set up your nodes. So now our cluster is also up and running with the nodes have been configured to our cluster. So the next step is to uh, update our kubectl context. So just take this command, paste it over here. So this will update our context for our cluster. And the next is to install the EBS CSI driver. So what is this EBS CSI driver? So let me remove the documentation over here. So here EBS CSI driver is like a add-on to our cluster. that helps to connect our pods to the EBS EBS storage here given. A plugin that allows Kubernetes to connect to different storage systems, because our EBS is external to our cluster, so there should be a way to connect it to our pod. So for that we are using the CSI driver. So to that, just take that command, take this command, and then simply hit it. So this will install those. It we have installed it via the Helm. So this is the reason why we installed Helm also. And next is identify the node group. So to now take this command, identify node group IAM, because we need it to help our cluster connect to those EBS CSI driver, because in our AWS we can have multiple Kubernetes cluster. We need a specific node group of this cluster to connect to those EBS. Paste it here and change the name of your node group and cluster name. So node group name is my cluster and cluster name is also my cluster, and cluster name is also my cluster, and simply hit enter. If we'll hit enter, you will get this IAM. You need to just copy this IAM from here. You take it till here, and then take this IAM policy, and you need to replace that with this role name. You took that and then copy this once again. So yes, now we have attached the IAM also. So next is simply install the driver. So apply this command to install that CSI driver, and your CSI driver will be installed. So now what I have done is I have created this project 3 directory, and inside that I have this KTS folder. This KTS folder is same as this. I have copied this KTS folder to this server. Inside this KTS folder I have those all files. So what we will do is we will apply all these files one by one now, and I will show you also that in our previous project we were creating PV and PVC manually, but in this video we will not create PV and PVC manually. Rather we will use this SC, that is storage class, and we will see how the PV and PVC are created dynamically and attached to your pods. Let's first see kubectl get ns. So we don't have any namespace called project 3. So let's first create the namespace, kubectl apply -f namespace.yaml. So this is a this creates our namespace. You can now check it. See here, namespace called project 3 has been created now. So now let's first apply the SC, and let me show you there is also a default storage class already present, kubectl get SC. See here, this is the default storage class that is already present, but now we will create our own storage class, and that name of that storage class will be cat sc, and name of our storage class will be AWS EBS. So let's apply that first. And also in our SC we have given as volume binding wait for the first consumer. Wait for the first consumer means our PV and PVC will not be granted to the pods immediately, but until that pod uses the backend. Let me show you that in hands-on, then it will get you clear. Now we have applied our SC. So let's see our SC once again. See here, now we have two storage classes. This one is default and this is the one that we have created. Reclaim policy is delete and volume binding mode is wait for the first consumer. What is this wait for the first consumer? I will explain it when I will apply that. So now let's apply the front end deployments and then we will apply MongoDB deployments and then the back end deployments. So let's apply first front end deployments. kubectl apply -f front end deployment. So front end deployment is created. Front end service also apply. So front end service is also applied. So these are the two parts of the front end and these are running, and this is the service for our front end which is a type cluster IP, and this is the deployment and this is the replica set. So now let's apply the backend stateful set. But before that we'll apply our, let's apply MongoDB only. kubectl apply mongo statefulset.yaml. So mongo statefulset.yaml is also created now, and now let's look into our get PV. See, a PV has been created and its status is bound now. We applied our MongoDB deployment about automatically a PV and PVC has been created. Let's check for PVC also. kubectl get PVC. Then shift 3. See here, stateful set Mongo data Mongo hyphen data Mongo hyphen stateful set 0 and stateful set 1, and its status as in bound. See, two and the ordered pod. Two pods have been two PVC have been created in ordered, and also PV also. See here, we have two PVs here. This is the one PV and this is the second PV, and those two are also in bound. And now see here, two pods of our MongoDB. Now let's apply the backend configurations. So backend configurations, we have backend config also. So let's apply first that. kubectl apply and then we have backend secrets.yaml, and then we have backend deployment.yaml, and then we have backend svc.yaml. Get all in them. See, all our configurations have been successfully applied and our resources are running. Two ports of MongoDB, two of front end, and two of database are up and running. But we never applied the service for our SVC, right? So let's apply first that. And for service for our MongoDB, and the name for that is here it is, headless service. So let's apply this. kubectl apply -f headless service. headless service is created. So Mongo service is also created and it's of a cluster IP none, which means headless service. And now we need to apply our ingress. And now you will see that your backend deployment is getting a crash loop back off. This is because it is not able to connect to our MongoDB pods, because our we have two MongoDB pods, and in that MongoDB pod we need to set up a replica set. What is this replica set is? So initiating MongoDB replica set in our one of the pod of our MongoDB, because we have applied stateful set, and in stateful set we have mentioned replica set as replica count as 2, which spins up the two pods of our MongoDB, and that two MongoDB are the replicas, but the data replication should be done by the MongoDB itself. So for that we will take this command and we will exec inside this first pod, that is Mongo stateful set 0. So we'll take this also, and we'll paste that, but our namespace is project 3. So now we are inside the MongoDB pod. So inside that, now take this one and paste it. So now this will initiate the replica set, and you can see the direct as secondary. And next you simply exit from here and check once again. Now that should be in running state. See here. And now we will install our Nginx Ingress controller. By once we will apply this, we will get a DNS for our Ingress, and then we will map that DNS to our domain name. So take this YAML, sorry, command, and come to your cluster and simply hit enter. So this will install a Ingress controller, and once this is applied, take this command. So you will get a DNS for that. See here, external IP DNS. So this is your DNS. Take that one. Sorry. Take that one, and let's take its IP now. To take its IP, what you need to do? You need to use this command, that is nslookup, and paste the DNS. So server can't found means it will take some time to give you to create this DNS. So let's wait some for a minute and then we'll try this once again. So now applied that command once again and I got this IP now. Take any one of this IP. So we will take this IP, and now we need to update our, if you have your working DNS, let's say you have your actual DNS, then you can map this IP to that DNS. As but I don't have the actual real DNS, what we will do is we will create our own custom DNS. Now we need to update our slash etc and slash host. So for that what we will do is come to your new notepad but run it as an administrative mode, and then come to files, open. So we'll open our slash etc slash host. So here all files, host, open. So in this now we will update that IP over here. So we'll update this IP. If you don't have this, you will just apply your IP here and then give a name here, myapp.local. and then simply save it. Just minimize this and come to your browser and just hit enter. Now let's apply the ingress kubectl apply -f ingress.yaml. So now ingress is also applied. Now see, you will be able to access your application. Now you can just simply log in into it. You are the new user, right? Let's log in at any of the user. See, you will be able to access your application. You are not seeing any stores because admin has not created any store. So that is the reason why I is not seeing the store. This is it. And your application is on this custom domain that is created by us. And if you have your actual real domain, then you can apply map your that DNS IP to that actual uh, domain name you have.